Homework handouts out. And should look something like this, only the front side should be completed and the back side we don't have to do yet. If you did, you're an overachiever, but you know, it's not entirely a bad thing. One step ahead of the game. I'm going to hold them up so I can see that the front side at least is completed. Excellent. Let's take a look at this very quickly and then we'll get back to working on the chapter review we had been working on yesterday. When asked to factor, what's always the first thing we check for when factoring, class? Common factor. And there is something common here, Brandon. 5. And when you pull out the 5, what does it leave us with, Maddie? And we look at that thing and we're like, that's a what? Audrey?
It's a difference of squares.
Difference of squares, and a difference of squares factors into what, Genesis? Sum and difference. So we should set up 2 sets of parentheses, one with a plus, one with a minus. What goes inside the parentheses here, Kendall?
M squared, and then 9.
There we go, but we don't stop there. When we see fourth powers, remember, those often factor further, and in this case, when we factor into a sum and difference class, we factored into a sum of squares and a difference of squares. Now, a sum of squares, remember, is prime. It will not factor further, just as the 5 won't factor further. Even if it did, we wouldn't care because it's a constant. But this difference of squares factors again, Michael, into
and plus 3 and minus 3.
Another sum and difference. How many had the complete factored form here on number 1? Questions. How many stopped one step too soon? How many only pulled out the common factor and stopped there? How many said this is a 5, m to the 4th minus 3 to the 4th, and you try to do a binomial polynomial, the thing that we're supposed to do for a sum or difference of the same odd powers. Oh, okay. Don't do that on the exam. All right, let's take a look at the next one. We have a 2x cubed positive 4x squared negative 18x negative 36. And of course, the first thing we always check for when we factor, Michael?
Common factor.
What's common, Michael?
2.
And we pull out a 2. What does it leave us with in parentheses?
X cubed positive 2x squared negative 9x negative. Let me see what I wrote down.
36 divided by 2?
I did this by grouping.
What's that? 36.
It's like 18.
18, there we go. So we can do this. All right. And then we look at this, and Michael's right. We got 4 terms, and we look at this first little group here, and hey, there's something common. And look at the next little group. Hey, there's something common. What's common to the first little group right here, Kendall?
X squared.
An x squared. If we pull out an x squared, it leaves us with?
X plus 3.
And in the next little group, what's common, Genesis? Good. Not just a 9, but a negative 9. And of course, we pull out a negative 9, it leaves us with? Negative divided by negative gives us a positive 2. And that's important because if it were an x negative 2, there's nothing further we could do. But because both of these 2 terms in the big parentheses have a common binomial factor of, Audrey, x plus 2, we can pull out that x plus 2, and it leaves us with what?
X plus 3. Well, x squared minus 9.
Yeah, and Audrey's like, I hate to even write that down because, you know, we all know it could go further into...
Plus 3x minus 3.
Yeah, and at this point we don't need the extra set of parentheses either, so we can just have the x plus 2 after the 2, and then x plus 3, x minus 3. Now, it is possible that instead of factoring out the 2 to begin with, you might have seen a 2x common and negative 18x common. And so it's possible you end up here with a 2x squared negative 18, or if you pulled out the 2, it gives you the x squared negative 9. You get it to the fully factored form. How many, regardless of the way in which you approached it, ended up with this here? Are there questions on this? And now we come to a cubed plus 27. And this could be considered what, Maddie?
Thing to the odd power. A positive?
Oh, a word that means we add. Help.
Sum.
A sum of
Cubes.
cubes, because we know that 27 is. And a sum of cubes, like the sum or difference of all odd powers, factors into a?
Binomial times a polynomial.
Binomial times a polynomial, though in this case it's specifically a trinomial, but any odd power we get binomial polynomial, where the binomial needs to be.
A plus 3.
And what about the trinomial or the polynomial here, Brandon?
A squared. positive 3a, positive negative.
Well, remember, anytime we've got the positive here, my sign's in the trinomial have to alternate. So a squared,
Negative 3a, positive negative.
there we go. And this would be our factored answer. How many got this for the third one in the factoring section? Questions on this? Questions? All right, let's take a look at the next section, which was to simplify or rationalize. Here we had a square root of negative 75 plus 2 times the square root of negative 12. Of course, anytime I see the square root of a negative, first thing I ought to do, class, pull out your I. So we could say I squared of 75 plus 2I squared of 12. But there's more we could do to simplify those radicals, and we have to, because can we add dissimilar radicals, class? No. So don't try to say, well, it's a 3i times the square root of 87. No. We don't add them until these match. So we're going to have to reduce them down. Kendall, I could maybe factor a 12, for instance. Let's take the easy one first and split it into
4 and 3.
where I can pull out a
2.
from the 4 to get.
4i times square root of 3.
And while we're at it, then, since this came to a square root of 3, in order to do the addition, we really want this to be 3 times something, and it is, Michael.
25.
And so I can end up with a
5i times square root of 3.
And now it adds just fine to get what, Genesis?
9i times the square root of 3.
9i times the square root of 3. And how many had that for the first part of number 2? Questions on that? Well, looking at the next one, we have the cube root of a negative 72m to the 8th n to the 4th. And let's go to Audrey. What do we do to reduce this down, simplify it down?
You pull out your I.
Do we pull out the I, class? Not for an odd root. The odd root of a negative isn't imaginary. The odd root of a negative is? Class? Negative. Now, odd root of a negative is just negative. So, cube root of a negative, that's just negative. We can split up the 72 into, say, 8 and 9, where I'm not focused on the 9 because it's not a square. I'm focused on the 8, where I can take the cube root to get
2.
And inside the cube root, don't forget to include your index. I'm going to need to keep the 9. And when it comes to the letters, class, when you take the root of powers, class, we divide the exponents by that index. And so we can say that 3 goes into 8, class, or, sorry, this is Audrey's problem. 3 goes into 8, Audrey. Twice with,
2
and the 3 goes into 4 with, and there we go. And this should have been our answer here. How many had negative 2m squared n times the cube root of 9m squared n? And it would do like Audrey did. Instead of a negative, you had an I instead. Okay, a couple of you. Okay, questions? Let's rationalize the denominator here on the next one, where we have 3 over the square root of 2. Of course, we know we can't have radicals in our denominator. That's not acceptable. And the key then is you have to take the root. But Genesis, you can't take the square root of 2. So what do we do?
Multiply top and bottom by 2.
Well, not by 2, but by the square root of 2, right? Which will give me what in my numerator?
3 times square root of 2.
But in the denominator, it becomes the square root of 4. Now I can take the root, and my final answer.
3 times the square root of 2 over 2.
And there we go. How many had that for the third one on set number 2? And the last one there on the set was 5 over the square root of 3 minus 1. We have a 2-term radical denominator, Maddie. What's the key here?
Multiply by the conjugate.
And we're going to have to multiply by the conjugate of the denominator, which is?
The square root of 3 plus 1.
And we're going to do top and bottom. Of course, before we do the bottom, got to do the top. And in the numerator, that's simply
5 times the square root of 3 plus 1.
5 squared root of 3 plus 5 we can distribute. But in the denominator, class, we've artificially created what special case? Sum and difference. So we can do what 3 things, class? And Maddie, back to you. When we square the first, we square the last, we put a minus sign between them. 3 minus 1 is 2. And if we do it all in our head, like being lazy and stuff, there we go. How many have that for the last one on number 2? Questions on this? Question. All right, let's drop down to the last thing. A couple fractions here, and we have this fraction, x squared negative 7x negative 30, all over a 2x squared negative 18. It said to simplify. Well, If I make this more simple, that's called reducing. So really we're just reducing, but the key to reducing fractions, remember, is you only cancel factors. Good, Kendall, you never cancel terms. So therefore, I must have factors in order to cancel. Brandon, how would I get some factors?
You backwards will x to x plus 3 and x minus 9.
All right, and that outer inner checks out. And then what about in the denominator, Kendall?
You can pull out a 2.
Good, always take the common factor first, which is,
X squared minus 9.
and of course that factors into,
X plus 3 and x minus 3.
I feel like we've seen a couple of these now, somehow in the same set. And now that everything's factors, now obviously class we can cancel the x plus 3's. What's our answer going to look like then, Genesis?
X minus 10 over 2 times x minus 2.
And one little statement we need to specify about this problem.
X can only equal to negative 3.
X can't equal negative 3 because the x plus 3 cannot be a 0. How many had this for that one? All right, and then the other one, under number 3, you had an addition problem. You had to, or subtraction problem, rather. You had to subtract. Well, I guess I wasn't technically wrong the first time, because do we ever really subtract, class? No, we add the inverse. So technically it is an addition problem. It's in disguise. But we can't really add or subtract fractions unless we have a common denominator. There we go, common denominator. And it's the key here, remember, is to draw the big long line. And we've kind of been doing this with our rational inequalities lately anyway. But what is the common denominator here, Brandon?
48.
It's a common denominator, work. Let's take it, let's do 48. And so that means we'll multiply top and bottom here by 6. And all your classmates are seething at you right now. Abby's crying. And that's just because she's sick. We do hope you get feeling better, Abby. We've missed you these last few days. And we multiply the 6 to get?
42x minus 24.
And then here, multiply top and bottom by 8. However, I want to keep in mind the negative here. So as we multiply the 8, or distribute the 8, making sure we apply the negative by changing some signs.
Negative 24x plus 45. 40.
And so we'll combine some terms. We have a 42x combines with a negative 24x to get 18x. And we'll combine a negative 24 with a positive 40 to get 16, all over 48. But we're not done because I can still do something to simplify. If you factor out a 2, it'll cancel. Or I said you can just cancel a 2 out of every value in the fraction to get
9x.
Take 2 out. 16 divided by 2 equals 8. There we go. All right, and all over 24. There we go. And the 24 is actually the LCD that I was planning to use to multiply by 3's and by 4's, but we'll get to the same answer as long as we see the reducing at the end. How many got that answer regardless of which way you went with this? Questions on this? All right, look back in your textbooks then at page 153. Page 153. And I want you to do numbers 21, 23, 25. Page 153, 21, 23, and 25. Very odd classwork assignment.
Wow. We're laughing at your jokes, just so I point that out.
That's the kind of joke I figured I could get you to laugh at. Now Gavin's crying. Make that a 35, not a 25. 21, 23, 35. What kind of equation is 21, class? Incomplete quadratic. What's the key?
It says, get the x squared by itself.
Isolate the x squared. (23), they do want you to solve by completing the square for practice sake. I know it factors really easily, but it's practice completing the square for the fun of it.
We have to. Oh, yeah,
Yeah, I wish they picked one that didn't actually factor, because when it does factor, it's like, it seems like such a waste to it the other way. I agree with you. But like I always say, you lose some, you lose some. Thank you.
You're welcome. Just
Audrey
remember that
Mouth
for the
did.
exams.
Audrey Mouth did. Just with you. Our church secretary is a graduate and former student of mine. Every now and then that line comes up. She still remembers it well. Like I always say, Miss Henderson, and she says, you lose some, you lose some. She knows. Finished? Thank you. Brandon finished? What was in the blank, Brandon?
136.
Good, because we half the 12 to 6 and then square it. Did we realize 35 won't factor? And I don't want to complete the square with that one. So formula it is. If you're good to go on 21, 23, and 35, you can go on to 37, 39, and 40. If you have questions, though, on the three that are on the board, raise your hand and ask. Brecken's raising his hand and asking, but I can't make out what he's saying. Send me an email, Brecken. Questions from those in here? Does anyone need these left up for a few more minutes? All good? All right, I'm taking down. All right, for sake of time, check your answers. Obviously, if you wanted to go back and rework these, maybe jot the answer down. You go back and rework it, make sure you're good. The first two are proportions. This one's really straightforward. This one, we had to do a little factoring and cancel away denominator factors. Remember, never cancel numerator factors that match, but denominator factors are okay to cancel away, and it makes it much easier to get negative 27. If you didn't, you'd have had a quadratic, which gives you negative 27 and negative 3. But negative 3 can't be an answer anyway. So just negative 27 here, not a proportion, not cross multiplying. Multiply everything by that LCD. Questions on 37, 39, or 40? All right, your homework for this evening is to do the backside of the handout that you did last night for homework. We'll take a look at that in our next lesson. And as we start wrapping up our reviews for your exam, again, the exam coming up in lesson 89. We have 2 more shorter lessons between now and then. All right, handout backside, exam Tuesday for you guys. Have a wonderful rest of your day, and you are dismissed.